I wonder if you have encountered these problems in the use of emulsifying mixer. 1. The powder is easy to agglomerate when put in. After agglomeration, it adheres to the stirring paddle and cannot be dissolved. How to ensure that they are fully dispersed in the tank under the circumstance of small proportion of active ingredients. 3. Occasionally, seal failure cannot be detected in time. Once it occurs, entire tank of material will be scrapped. 4. It is difficult to clean high-viscosity materials, and the internal mixing structure of the emulsifier is complicated, with many gaps, making it more difficult to clean thoroughly. 5. Temperature overcharging is easy to occur during heating and cooling. Sometimes the temperature difference between the upper and lower layers of materials can be greater than 10 degrees, which seriously affects product quality, even causes some processes to fail to be realized. These 5 problems are common problems that everyone will encounter in the use of emulsifiers. They are homogenizing performance, stirring performance, sealing performance, heat transfer performance, and cleanability of the emulsifier. Next, I will share with you our problem-solving ideas. That is our 5th generation emulsification technology. I will share with you a specific implementation case of using our emulsification technology to reduce costs and increase efficiency in making sterile ointment. Finally, I will share another method of how emulsifier equipment can achieve energy saving and emission reduction. First of all, we are talking about the core competence of an emulsifying mixer, the homogeneous performance. The quality of homogeneous performance directly affects whether the product can be made and whether the product is stable. Everybody knows the key parameter that affects the homogenizing performance is rotation speed, which is true but not entirely true. The key of homogenizing is the stator-rotor system. Homogenizing speed is also the speed of the rotor. Under the conditions of same diameter, same tooth shape, and same stator-rotor gap, the faster the speed, the better the effect. Combining these 4 parameters, we get another parameter, shear rate, which can be calculated by this formula. The level of shear rate can be used to describe the emulsification effect, or whether it is fine or not, that everyone mostly concerns. You may have noticed that one of the parameters described in this formula seems to be missing. Yes, the tooth shape cannot be described here. So how to optimize this variable? We have introduced CFD simulation technology here to analyze the entire flow field state of the stator and rotor, as well as materials with different viscosities, whether they are Newtonian fluids or non-Newtonian fluids. We analyze them at the microsecond level. After a lot of calculations and comparison of calculated data, we found a special rotor has changed from the original single-layer or multi-layer comb structure to a multi-layer composite structure, and different layers can have different functions and roles. Combined with the special configuration of the rotor, the feeding method of the emulsifier has also changed from the traditional top feeding to bottom suction. The inhaled raw materials will quickly meet the raw materials in the tank and be sucked into the stator and rotor immediately. To obtain sufficient homogenizing dispersion just mentioned in one fell swoop, That is the agglomeration phenomenon. Because the powder enters the stator and rotor as soon as it is inhaled and is discharged together with the liquid material after being dispersed. At the same time, this method can also double the work efficiency. It is no longer necessary to spend time in exchange for the uniform dispersion of the material like the traditional emulsifying mixer, because the material has been dispersed as soon as it enters. After testing this solution in the production of cold sauce, and its processing efficiency is 6 times higher than that of traditional emulsifying mixers, the original 30-minute batch has reduced to the limit of 5 minutes to complete a batch. Some customers even achieved 4.5 minutes, which includes the feeding and discharging time. In addition to the configuration, the speed of the rotor is also very important. So let's put it in the fourth article together with seals. In sections 2 and 3, I'll be talking about mixing performance and cleanability. Why should these 2 points be mentioned together? Because the most difficult part to clean in an emulsifying mixer is the complicated set of stirring paddles. The reason why the traditional emulsifying mixer needs the complex bidirectional counter-rotating wall scraping paddle is to make the high viscosity materials. But some materials may go through 10 times, some materials only pass through once. Which will cause the second problem mentioned above. That is unevenness. For traditional emulsifying mixer, it needs continuous stacking, operation time to expect all the materials to be emulsified evenly. But the emulsion may also be broken after long time stirring, which tests the ability of process control. The one in the video is the traditional emulsifying mixer's homogenizing and stirring structure, 3 concentric axes, which everyone mostly familiar. A counterclockwise rotating wall scraping impeller, a clockwise rotating central impeller, and a high-speed stator and rotor in the center. The homogenization method adopted by the 5th generation emulsification technology is avoid stacking time blindly. Materials can obtain sufficient homogenization. Continuous exchange of upper and lower materials for homogenization can make the whole tank of materials obtain an approximate homogenization result. One in the picture is the feed inlet. Liquid material or powder material meets original material from here, the tank, and then it is quickly sucked into the stator and rotor after premixing. After breaking up in rotor and stator, return to the upper layer of the liquid surface via the external circulation pipeline 11. This mechanism can exchange the upper and lower materials, which reduces the burden on the stirring blades. No longer need a complicated structure such as bidirectional, counter-rotating stirring. Simple structure can also obtain higher efficiency. The simplified paddle is very easy to design and process. It can realize no gaps below the liquid surface. It can realize no gaps below the liquid surface. In addition, the paddle rotates in both directions, which avoids the shady side during cleaning and greatly reducing the difficulty of cleaning. The fourth section is sealing performance. This point is still combined with special homogenizing and stirring structure of equipment. This homogenizing structure optimized by CFD simulation technology has a relatively simple transmission structure while improving performance, which means that it has greater choice in sealing installation. We have selected this internationally advanced sanitary cartridge mechanical seal, which is characterized by easy installation, durability, the rotating speed is high. The assembly type can greatly reduce the installation difficulty and accuracy of mechanical seal. Ordinary operators can master the main points of replacement after a few minutes of training. For the overall cleanliness of the equipment, the cavity of this mechanical seal can also be cleaned and sterilized. With the assistance of this type of seal, homogenizing speed of the fifth generation emulsifying mixer can easily exceed 4,000 revolutions per minute. This also can reach 6,000 revolutions per minute of the equipment again. However, no matter how advanced the seal is, there is no guarantee that it will never leak. So we added a set of insurance for it, which is a set of self-test procedures for equipment availability. You can perform this set of inspection procedures periodically or before every batch, and the program will automatically check for possible problems with the equipment. It only takes half an hour to complete the whole process. If there is a problem, a warning will pop up to tell where there may be a fault. If everything is normal, you can use the device with confidence. This solution can detect problems as early as possible. When found early, they are small problems. After simple treatment or replacement of wearing parts, the equipment can be restored to the original state. If it is not discovered early, it may affect the production schedule and even the service life of the equipment when it is dragged into a major problem and then eliminated. Chapter 5. Let's talk about the heat transfer performance. For our pharmaceutical industry, the emulsifying mixer is mainly used to produce creams, gels, and similar products. The characteristics of this type of material are high viscosity and low heat transfer performance. The key to heat transfer of this type of material is to take away the heated material on the tank wall in time. Replace unheated material for heating. Only by reciprocate heating can the material be fully and evenly heated in the tank. The Tefy wall scraping form of our 5th generation emulsifying mixer has changed from the original passive scraping to the current active scraping. The scraping force of the passive scraper comes from the pressure of the material body on the scraper during stirring. And this pressure is unstable with the change of stirring speed and the change of material viscosity. When the pressure is insufficient, effective scraping will not be formed. If the pressure is too high, the wear of the scraper and the wall will be accelerated. Active wall scraping can solve the existing problems very well. The pressure of the wall scraping is provided by elastic body. No matter what speed, its pressure on the wall is constant, which can ensure that the wall scraping is always effective. Slow stirring can also obtain effective scraping wall, and there is no need to worry about accelerated wear when stirring quickly. Combined with the special mixing system, the heat exchange of materials can be fully, quickly, and uniformly achieved. This is the key point of our latest emulsifying technology. You may not understand why I call it the 5th generation emulsifying mixer. Okay, this is actually our internal classification of emulsifying mixer technology. In the 25 years of development, our emulsification technology has undergone 5 major iterations. We have defined it for the convenience of distinction. In order to further understand the technical root of our emulsifying technology, let me take you through it briefly. The core function of the emulsifying mixer is high shear homogenizer. The initial emulsifying mixer was realized by simply adding a tank on the basis of the homogenization pump and homogenizer. This was our product in 1998. At that time, it is significantly behind the international advanced level, but it is what our first generation emulsifying mixer looks like. Very simple. Summarizing the problems feedbacked by customers in use and referring to foreign advanced designs, we launched the second generation emulsifying mixer in 2004. The most typical feature of this generation of products is the integration of various functional items. The tank body, homogenizing, and stirring structures are installed on the same frame. The vacuum system, heating and cooling system, and control system are installed in the chassis. At this time, due to technical limitations, the agitator in the tank only has a frame type or anchor type agitator for unidirectional stirring, but there is already scraping wall stirrer. After several years of research and development and summary of experience, in 2008 our company developed the third generation of emulsification technology. The typical features of the third generation technology are bidirectional, counter-rotating scraping wall stirring, and various forms of replaceable high shear homogenizers. Addition of PLC control can realize automatic operation. The working principle of the third generation technology is mentioned in previous sections. Due to the limited suction range generated by the stator and rotor, in order to make all materials, especially viscous materials, pass through the stator and rotor, a set of stirring paddle is needed to assist. But in this system, it is unknown whether the material has passed through once, 10 times, or not. It can only be realized by stacking time. This is a test of the technical design, and the production of full cans and half cans will both have impact on process time. But anyway, the structure and performance of this third technology is very reliable, which has become our best-selling, most stable and most reliable emulsifying mixer product for 15 years. I believe it is also the most familiar form of emulsifying mixer for everyone. The research and development of equipment must always keep pace with the needs of users. With increasing demands for CIP and CIP in the pharmaceutical field, obviously previous complex mixing structure is difficult to meet new needs, so the fourth generation of emulsifiers came into being. The fourth generation emulsifying mixer began to use finite element analysis and CFD simulation technology on a large scale during the design process, on the basis of ensuring that the emulsification effect does not decrease. The homogenizing and stirring structure is simplified as much as possible. The fifth generation technology is actually a continuation of the fourth generation technology. The emulsification operation mode of the fourth generation technology is very similar to that of the fifth generation. Rotor from the bottom and is fully homogenized, then returns to the upper layer of the liquid level, and can also provide power for cleaning through the switching of pipelines. The fifth generation technology is the result of further optimization on this basis. Let me share with you the cases of using fifth-generation technology. One is that it can greatly reduce the loss of materials in small batch production. And the other is how to save energy and reduce emissions, which is a hot issue in today's society. The biggest feature of this situation is that the output is small. The biggest fear of small batch production is loss, especially some raw materials in medicine are very expensive. We made full use of the characteristics of simple structure and small volume of the fifth-generation emulsifying tanks and design such a structure. The preparatory tank is placed in the C-class area in a separate room. After the pretreated material is sterile filtered, it is sucked into the emulsification tank in the next room by vacuum pump. The emulsifying part adopts split structure, emulsifying tank and dock. This is the biggest feature of the package. We put electronic control, batching, cleaning, sterilization, and other equipment in a fixed position, which is called dock. After the mobile emulsifying tank is pushed onto the dock lifts the emulsification tank off the ground and then connects the pipeline system to combine an emulsifying mixer, which realizes batching, heating, cooling, vacuuming, stirring, homogenizing, CIP and SIP function. This is what they look like together after the configuration is completed and the valve on the emulsification tank is closed. After rolling out, seal the emulsifying tank and transfer it to the filling room. Then put the lifting frame to lift the emulsification tank to the high-level tank of the filling machine. And then connect the pipeline of the filling machine, and the emulsifying tank replaces the high-level tank. In this way, pipelines and high-level hoppers for feeding material liquids are omitted. After filling is completed, pushes the emulsifying tank to the dock, and after the dock and the tank are combined, the tank can be connected to the system for CIP cleaning together with the preparatory tank. Such a set of solutions can greatly reduce the loss of materials during transfer, increase the recovery rate, and greatly reduce parts do not need to be cleaned and sterilized, which reduces costs and increasing efficiency, especially suitable for small output configurations. Finally, I would like to share with you what I think is the most interesting feature of our fifth-generation emulsification technology: energy saving and emission reduction. Although our new technology has greatly improved the efficiency of stirring and heat exchange, which is also very helpful to the energy saving and emission reduction of equipment, but as long as we pursue better emulsification effect, we will inevitably need a higher shear rate. This goes back to the formula we mentioned at the beginning. Under the circumstance that other conditions remain unchanged, if you want better emulsification effect, you need to increase the rotor speed, or increase the diameter of the rotor, or reduce the gap between the stator and the rotor. Conditions, it is obvious that the third condition has a limit to reduce the gap between the stator and the rotor. It is limited by the transmission structure and machining accuracy, and cannot be reduced without limit or be reduced much. For the other two conditions, increasing the rotational speed and diameter will increase the energy input, especially the rotational speed, which has a cubic relationship with the driving energy. This is the value of this energy saving and save energy and reduce emissions at the same time. We change the installation method of the homogenizer and the opening method of cover of the equipment. Maybe you will ask if it is just to change the way of opening the cover. How much power can this save? Yes, this does not save much power, but combining these 2 points can save the room height of the overall configuration. Yes, it is not the equipment itself that saves energy, but reduced environmental energy
Taking the
consumption.
500 kilograms emulsifying mixer as an example, the height of the machine room of the traditional emulsification machine is not less than 4.6 meters, while the height of the machine room required by the fifth-generation emulsification machine is
Calculated
only 3
on the
meters,
basis of
which
a
saves about
1.5
1.5
level
meters
workshop.
space
It can
in height.
save
About
about
35,000 kilowatt hours of
meters of
electricity
clean
a
workshop
year.
space.
Calculated according to the service life of the emulsifying mixer, it should not be less than 10 years. In just 10 years, the savings on electricity bills can be used to buy new equipment. Okay, this is the iterative update of 5 generations of emulsifier technology. In the 25 years we have been going all the way, but we have been always making progress. Our 6th generation technology is about to come out, and we propose 3 higher technical indicators for this generation, which are higher intelligence, higher shear rate, and higher flexibility. This is a generation of products built for the realization of the dark factory. You can look forward to it. It has been developed and is being tested and optimized, which is expected to launch early next year. Thank you, everyone, and that's all I have to say today. I am Zhang Shengsheng, the Technical Director of Wuxi Yeki Automation Technology, Co., Ltd. Our company was established in 1998 and has been focusing on the research and development and production of emulsifier products for 25 years. Maybe our experience can be helpful to you. Thank you.